In question 5, we have a low carbon structural steel in a railway bridge, and it fractured in a brittle fate at a cold environment. No fracture or ductile fracture, however, was observed on the similar parts made of austenitic stainless steel. What might be the possible cause of this fracture? Why do you think stainless steel part is not fractured, although it supports the same kind of stresses? So this question is now related with the amount of energy that a material can absorb under different stresses. So this behavior is determined with impact testing, and the result of impact testing is impact energy versus temperature. So if you draw a hypothetical impact energy in joules versus temperature in Celsius curve, now different materials show different behaviors. For example, generally BCC metals such as steels will show a transition behavior. So at high temperature, it's going to behave like ductile, high amount of energy absorption, and at low temperatures this is going to be brittle. And there is a transition region known as ductile to brittle transition. So this behavior is generally observed for BCC materials, and for FCC materials we generally do not observe this transition, and they will have approximately same values, or at low temperatures the impact energy is going to be lower, but not as significantly low as the BCC metals. So if we superimpose the two materials, they're going to behave like this. And in your textbooks, you can see that for BCC metals the impact energy is given like this. For high strength materials the impact energy is low, but for FCC and HCP metals we have high impact energy values and they do not show any transition. So the reason of brittle fracture of the structural steel but no brittle fracture of the FCC steel can be explained by the ductile to brittle transition.